Good evening, everyone. So tonight we will tackle about infiltration. So what is infiltration? From its denotational meaning is the flow of water from above the ground into the subsurface from rainfall or irrigation. Percolation is the process of water flow from one point to another. Percolation comes, comes from the Latin word percolare, meaning to strain through. Percolation is the process of a liquid slowly passing through a filter. The difference between infiltration and percolation is that infiltration is the movement of water into soil, while percolation is the downward movement of water within the soil. So infiltration and percolation both plays an important key role in surface runoff, groundwater discharge, evapotranspiration. This evapotranspiration will be discussed further by the next reporter, but when we say transpiration, uh, it is the process of water movement through a plant and its evaporation from aerial parts such as leaves, stems, and flowers. Also, infiltration and percolation plays an important role in soil erosion and transport of chemicals in surface and subsurface waters.
Definition of terms. Surface runoff. Surface runoff is a water running off in the surface or subsurface of the land which causes precipitation. Also can be described as water flowing over soil, vegetation, or other ground cover instead of infiltrating to the underlying soil. Groundwater recharge. Groundwater recharge is a hydrologic process where water moves downward from the surface water to groundwater. Recharge is a primary method through which water enters an aquifer. Evapotranspiration. Evapotranspiration is the sum of evaporation from the land surface plus transpiration from plants. Also, it is a loss of water from the soil both by evaporation from the soil surface and by transpiration from the leaves of the plants growing on it. Soil erosion. Soil erosion is a natural occurring process that refers to the wearing away of a field's topsoil. Soil erosion is a gradual process of movement and transport of the upper layer of soil by different agents such as water, wind, and mass movement, causing its deterioration in the long term. In other words, soil erosion is the removal of the most fertile top layer of the soil through different agents. Infiltration capacity. Infiltration capacity is the maximum rate at which soil and rocks can absorb water. The infiltration capacity tends to decrease as the soil moisture content of the surface layers increases. It also depends upon such factors as grain size and vegetation cover.
Factors that affect infiltration. Infiltration capacity, a rate of which a given soil at a given time can absorb water. It is said that the infiltration capacity of the soil is high at the beginning of the storm and has an exponential decay as it elapses. The infiltration capacity of an area is dependent on a large number of the following. Condition of the soil surface. Even if the subsoil has an excellent under drainage, but at the surface, soil pores are sealed due to the turbid water or by inwash of fine soil particles. It may prevent entry of water into the soil and the infiltration rate will be low. Current moisture content. When the soil is fairly dry, the rate of the infiltration into the soil is quite high. The infiltration rate diminishes as the soil moisture storage capacity is exhausted. After this, infiltration rate equals transmission rate. Vegetative cover. It affects surface entry of water significantly. The vegetation or mulches protect the soil surface from the impact of raindrops. The lengthy and extensive root system penetrate the soil and increases its porosity. Soil temperature. If saturated soil mass gets frozen due to severe low temperature, it becomes nearly impermeable. It affects the infiltration. Characteristics of the soil are texture, porosity, and hydroconductivity.
Characteristics of soil. Soil is an unconsolidated aggregate of mineral and rock fragments ranging in size from clay, silt, sand to gravel. The type of soil, texture, structure, permeability, and under drainage are important characteristics under this category. When the soil occurs in layers, the transmission capacity of the layers determines the overall infiltration rate. Seen on the slide is a table of the infiltration rate of the different types of soil. It shows the infiltration at capacity rate measured in millimeter per hour and the time from start of infiltration which is measured in hours. Infiltration rate is measured by recording the rate at which water enters the soil. But the rate at which water infiltrates the soil is not constant. Generally, water initially infiltrates at a faster rate and slows down with time. When the infiltration rate slows down to a steady level, or where the curve flattens off the table, the infiltration capacity has been reached. This is the rate of infiltration when the soil is fully saturated. Therefore, as seen on the table, the wet clay loam has high infiltration rate compared to dry sand loam, and both of them depreciate as time goes by. Moreover, between forest soil and urban soil, forest soil will have much higher infiltration capacity in under identical conditions compared to the urban soil where it is subjected to compaction. The reason is that impervious surfaces in urban settings mostly do not allow any infiltration. In order to build load-bearing structures like buildings and roads, the soil in urban areas needs to be heavily compacted. This process breaks down the structure of the soil, filling the pore space with soil particles and eliminating space for air and water. Whereas areas with trees generally have greater infiltration rates because they have a network of well-connected channels in the soil called macropores, which is where the water is held. Flow through these macropores can be up to several hundred times faster than flow through the soil matrix. In addition, organic matter from leaf litter and tree roots improve soil structure, which can increase infiltration.
So I will be discussing another factor that affects infiltration, which is surface of entry. So it is defined as an important factor affecting the infiltration capacity. So as discussed, capacity is the amount of water in which a given soil can hold. There are two key components of water holding capacity, which is soil texture and organic matter. In terms of soil texture, small particles such as silt and clay tend to have a large surface area. Sand, on the other hand, has large particles, particle size, which means they have a small surface area. At the soil surface, raindrops causes the fines in the soil to be displaced, and this causes to close the small pores located at the soil surface. So when the rain drops and hits the earth's surface, there are two likely things to happen. First is the water will run off, or second is the water will infiltrate into the soil. So when a raindrop hits the bare soil with enough force to break the soil aggregates, these fragments wash into soil pores and prevents the water from infiltrating to the soil. Water accumulates on the surface and increases runoff, which takes the soil with it. Thus, a surface covered with grass and other vegetation can affect the process of infiltration. A well-structured soil is less prone to break up, and the impact of raindrops is minimized if the soil surface is protected by plants. Vegetation allow Vegetation allows greater infiltration because the roots of the plants actually absorbs the excessive water.
Characteristics of fluids. Fluids have certain characteristics that define them as fluids. For example, fluids do not have a definite shape of their own. Instead, both gases and liquids take the shape of their container, seen in Figure 1. Although liquids do not have a definite shape, they do have a definite volume. If you pour 500 ml of a liquid from a tall, thin container into a short, wide container, its volume is still 500 ml. Characteristics of fluid flow: steady flow, laminar flow, streamline flow. The fluid velocity, both magnitude and direction, at any given point is constant in time. The flow pattern does not change with time. Non-steady flow, turbulent flow. Velocities vary irregular with time. Rapids or waterfall. Rotational and irrotational flow. The element of fluid at each point has a net angular velocity about that point. Otherwise, it is irrotational. Example: whirlpools. Compressible and incompressible fluid. Liquids are usually considered as incompressible. Gas are usually considered as highly compressible. Viscous and non-viscous fluid. Viscosity in fluid motion is the analog of friction in the motion of solids. It introduces tangential forces between layers of fluid in relative motion and results in dissipation of mechanical energy.
Of infiltration using flood type infiltrometers. Since it measures the infiltration characteristics at a spot, only a large number of pre-planned experiments are necessary to obtain a representative infiltration characteristics for and the entire watershed. There are two types of flood type infiltrometers. There is double ring infiltrometer. A double ring infiltrometer requires two rings, an inner and outer ring. The purpose is to create a one-dimensional flow of water from the inner ring as the analysis of the data is simplified. The single ring infiltrometer uses one ring which is dug into the soil and supplying water in the entire ring either at a constant head or falling head condition. Then another type of measurement of infiltration, we have rainfall simulator. Many simple simulators have used the simple principle of drops forming and dropping from the tip of tubes connected to a water supply. Another one is what we call the hydrograph analysis. A reasonable estimation of infiltration capacity of a small watershed can be obtained by analyzing measured runoff hydrography and corresponding rainfall records. Hydrography is a continuous record of river discharge or water discharge, and the shape of a hydrography is a response from a particular catchment of series of unique conditions ranging from the underlying geology and catchment shape to the antecedent witness and storm duration.
Flooding type infiltrometer, used to obtain data relating to variation of infiltration with time. So there are two types of infiltrometer. There is tube type infiltrometer, or also known as a single ring infiltrometer, and the other one is double ring infiltrometer. So the single ring or tube type infiltrometer is involves driving a ring into the soil and supplying water in the ring either at constant head or falling head condition. And at the end, the operator records how much water goes into the soil for a given time period. So, a double ring infiltrometer is an instrument which is used to determine the infiltration rate of water into the soil. The infiltration rate is determined as the amount of water per surface area and time unit which penetrates the soil. So flooding type infiltrometer, since it measures the infiltration characteristics at a spot, only a large number of pre-planned experiments are necessary to obtain a representative infiltration characteristic for and the entire watershed. So there are disadvantages of this kind of infiltrometer. First is raindrop impact effect is not stimulated. Second is the driving of the tube or rings disturb the soil structure. And lastly, the results of the infiltrometers depend to some extent on their size, with the larger meters giving less rates than the smaller ones due to the border effect.
A rainfall simulator is used in soil science and hydrology to study how the soil reacts to rainfall. Natural rainfall is difficult to use in experimentation because the timing and intensity of rainfall events cannot be reliably reproduced. Using simulated rainfall events significantly speeds the study of erosion, surface runoff, and leaching. Many simple simulators have used the principle of drops forming and dropping from the tip of tubes connected to a water supply. The size of drop is related to the size of tubing. Metal, glass or plastic tubing has been used, or hypodermic needles, which are manufactured to a high degree of accuracy. An array of tubes of different sizes may be used to produce rain of different size drops, and also it gives lower values than flooding type. Here are some of the advantages and disadvantages of rainfall simulators. One of its advantages is the size of the drops and their fall velocity are constant. The distribution of rainfall across the test plot is uniform and can be achieved with low water pressures. However, its disadvantages are unless the device is raised up very high, the drops strike the test plot at a velocity much lower than the terminal velocity of falling rain, and therefore the values of kinetic energy are also low. A large drop of 5 millimeter diameter needs a height of fall of about 12 meters to reach terminal velocity, and this is difficult to achieve in field conditions. To some extent, this can be compensated by using larger drops than in natural rainfall. Another disadvantage is that the size of the test plot is limited by the practicalities of constructing a very large drop forming.
Lastly, hydrograph analysis. A reasonable estimation of the infiltration capacity of a small watershed can be obtained by analyzing measured runoff, hydrograph, and corresponding rainfall records. A hydrograph is a continuous record of stream or a river discharge, and also it is a basic working unit for a hydrologist to understand and interpret the shape of a hydrograph. Also, it is a response from a particular catchment to a series of unique conditions, ranging from the underlying geology and catchment shape to the antecedent wetness and storm duration. Involves dissecting a hydrograph to distinguish between storm flow and base flow. This is often a precursor to using the unit hydrograph, a technique using past storm flow records to make predictions on the likely form of future storm events. It is somewhat related to or looks like an earthquake seismograph, though it is this kind of analysis is used to check the kind of soil wherein the storm flow is being designated. And as said, it is often used to make predictions regardless to the pattern of the storm for future events. And that's all for our topic in regarding infiltration. Thank you and God bless.